Welcome back, everyone, to this lecture series on data frames. So throughout the course, most of our data exploration is actually done with data frames. And data frames are an extremely powerful tool and really just a natural extension of the Pandas series. And a data frame is a table of columns and rows in Pandas that we can easily restructure and filter. And as a formal definition, a data frame is simply a group of Pandas series objects that share the same index. And that's actually a really important definition and distinction to make. So let's quickly define this a little visually. So here we have an example of just a single series, something we're already used to from the previous lecture, where we have a labeled index, and then we have some data columns, such as the year. Now here we have an example of multiple series that are actually sharing the same index. You'll notice that each of these individual 3 series actually has the same index, USA, Canada, Mexico, and so on. And so what we can do is combine these 3 series that share the same index into a single data frame with the same index, just with the multiple columns. And so that's all a data frame is. It's just several series that happen to share the same index. So this looks a lot like a spreadsheet, which is essentially what it is at a very high-level overview, where each individual column is just a Pandas series, and they all just share the same index. Okay, let's get started showing you how to create a data frame from Python objects. I'm going to head over to a Jupyter Notebook. All right, here I am at the Jupyter Notebook. I'm going to go ahead and say import numpy as np and import pandas as pd. And I'm going to do one last thing here. I'm going to say from numpy.random import randn. And then I'm going to go ahead and set a seed. And what a seed means is just to make sure that we get the same random numbers. That way, if you're following me, you'll see the same random numbers that I see. So you can go ahead and say np.random.seed. All right, let's go ahead and explore the data frame command. I'm going to say df is equal to pd.dataframe. And you can actually use tab here if you're using Jupyter Notebook to autocomplete this. And notice that the F is capitalized. I'm going to do Shift Tab to check out the doc string and the initial signature for this PD data frame. We have a data argument and an index argument, just like we did for series, but then we have this additional columns argument. Let's go ahead and build this up with some random data, and we'll see what a data frame actually looks like. First thing I'm going to do is pass in that data argument, and I'm actually just going to call it randn 5, 4. And then the next ones we want to pass is the index. And the index, we can just make that a list of characters here. I'm going to go ahead and say A, B, C, D, E. And then finally, for the columns, I'm going to go ahead and say W, X, Y, Z. So I'll say W, X, Y, Z. I'm going to go ahead and run this and then pass in the data frame, just display it. And there we get a nice display, and this probably looks and feels a lot like Excel if you're using a Jupyter Notebook, and that's good. If you're using another IDE editor, you may not get such a nice crisp display, but you should get a printed output that looks similar to this. All right, so basically what we have here is a list of columns, W, X, Y, Z, and corresponding rows, A, B, C, D, E. Now, each of these columns is actually just a Pandas series. So W is a Pandas series, as well as X, Y, and Z. And they all share a common index. And that's basically all data frame is. It's just a bunch of series that share an index. Let's go ahead and show how we can use indexing and selection to actually grab one of these series objects, or several of these columns out. One way, and the main way to do this, is by saying df, and then using bracket notation, and then passing in the column name. In this case, let's go ahead and grab the W column. So as a string, I'll pass in W, and this returns the W column. And now take a look at the output. Now this actually looks like a series. And that's because that's exactly what W column is. It's just a series. And you can actually confirm this by saying type of df of W. And it shows that it's pandas.core.series.series. If I just say type on the df object itself, I will get a data frame out. So again, just to reiterate that fact that a data frame is just a bunch of series that share the same index. Now, there's two different ways you can grab a column from a data frame. the main way and the way you should always do it is using this sort of bracket notation and then pass in the column name. However, if you're really familiar with SQL, a lot of times you're selecting a column, you pass in a table, dot, and then the column name. This actually also works for Pandas. You could say dot and then the column name. However, I would recommend that you don't use this because it may get confused with the various methods that are available off of the data frame. For instance, if I say df dot and then click tab, I see a whole bunch of methods available for me. And those are a bunch of methods that we're going to learn about as we learn more about Pandas. But what may happen is that one of these methods gets overwritten by a column name. And then Pandas is going to get confused whether you're asking for a method or an actual column name. So what you should do to avoid that is always use this sort of bracket notation when requesting a column. Okay, if you want multiple columns back, then you can go ahead and pass in a list of columns. So note that I pass in my brackets and then I'm going to pass in a list of column names, which is going to result in another set of brackets here. For instance, if I wanted columns W and Z, I pass in a list here highlighted, W and Z, and I get back a data frame containing those two series. And that means when I ask for multiple columns, I'm actually getting back a data frame. If I ask for just a single column, then I will get back a series. And in the Jupyter Notebook system, that's denoted by the way the output is displayed. Okay, let's go ahead and move on to creating a new column. Pandas supports creation of new columns by just specifying the column as if it already exists. For instance, new. Now if I run this, I'll get an error. And it's a key error. If you scroll all the way down here, it'll say key error, new. And it basically just is trying to tell you that it can't find it, that there is no key new there. However, when you're creating let me go ahead and hashtag that out and put this back in. When you're creating a new column, you can actually define it as if it already exists. And then on the right-hand side of this equal sign, use other columns with arithmetic in order to pull off a new column. For instance, we can say df new column as if it already exists is equal to dfw plus dfy. And this will run with no error. And now if I check out df, that new column is actually in place there. And for removing columns, you can say df.drop. You can say df.drop and pass in the actual column name you want to drop. Now, if you just do this by itself, you'll get an error. And let's go ahead and check out what that error is. It'll say value error, and we scroll down, it says labels new not contained in access. And if I click Shift Tab on the drop method, notice that by default it says access is equal to 0. Access is equal to 0 for the drop method refers to the index. If I actually want to refer to the columns, I need to specify access is equal to 1. And then it will drop that new column here. Now there's two things to note when using this df.drop. The first thing to note is that this doesn't happen in place, meaning I'm not actually affecting this data frame unless I specifically specify this to occur in place. I'm going to go ahead and show you what I mean by that. I've called this line df.drop new access equal to 1. If I call df, I'll see that I still have that new column. That means I need to actually specify as an argument, I will do Shift Tab to show it, the in-place argument. And many Pandas methods will require this in-place argument to be set to true. And the reason Pandas does that is that for you not to accidentally lose information. In case you've done a bunch of adjustments to your data, you don't want to accidentally lose it. So Pandas requires you to say in place equals true if you actually want a lot of these changes to stay and occur in place. And now if I call df by running this cell, notice that new column is now permanently removed because it occurred in place. And something to note here is that we can also use df.drop to drop rows. For instance, let's go ahead and use this to drop the E row. I'll say df.drop. I pass in E, and I can also say access is equal to 0. Now remember, you actually don't have to add that in as an argument. That's the default. So let's go ahead and just say df.drop E. And there we've been able to drop the E since access is equal to 0. And it works either way. I could say access is equal to 0, and this will work again. And note here, I'm not doing this in place. Okay, sometimes a point of confusion is why are the rows 0 as far as their access and why are the columns 1? Well, a reference actually comes back to NumPy, since data frames are essentially just fancy index markers on top of a NumPy array. To show this, I can say df.shape, just like we did with a NumPy matrix. And note, df.shape is a tuple for a two-dimensional matrix here. And at the 0 index are the number of rows. So if I say df here, I have 5 rows, A, B, C, and D, E. And then on the index 1, I have 4 columns, W, X, Y, Z, which is why rows are referred to as the 0 axis and columns are referred to as the 1 axis because it's directly taken from the shape, just as you would with a NumPy array. Okay, now let's talk about selecting rows. We've talked about selecting columns, which you just do by saying df, and in brackets, you pass in the column name. Or, if you want many columns, you pass in a list of the column names, such as Z and then comma X. Let me close off that bracket. So I'm passing a list of column names, and I return a data frame of those multiple columns. Let's talk about selecting rows. I'm going to take a look at my data frame again. Here's my data frame. A, B, C, D, E is my rows. W, X, Y, Z are the columns. There's 2 ways to select rows in a data frame. And you have to call a method off of this. And there's 2 methods to use. One is loc, L-O-C for location. And this is going to take in a label. So you can also do Shift-Tab here to see this property. And something to note here is I'm using square brackets, which is a little weird, but that's the way it works with pandas. You pass in .loc, and then you pass in brackets, the row you want. For instance, if I wanted an A row, I just pass in .loc, I pass in the label of that index. And this returns, note, a series. And this comes to our second conclusion that not only are all the columns series, but the rows are series as well, as far as the way they're going to get returned when you request them in pandas. Now let's discuss the second way to grab a row, which is based off of index position. I can use df.iloc to actually pass in a numerical index position even if my axes are labeled by strings. For instance, if I want C, that row, I can do that 2 ways. I could either say df.loc for location and in brackets pass in the row name, which is C, or I can say iloc, which is index-based location, and count what index it's at, so 0, 1, 2. And then on iloc, pass in 2, and this also returns that row. And that basically means you have 2 ways of selecting rows, using LOC if you want the location or labeled-based index, or iloc if you want the numerical-based index. Okay, let's talk about selecting subsets of rows and columns. And this will actually be very familiar to you since we just learned about NumPy. We can say df.loc if we want to select a subset of rows and columns. We can pass in, just like we did with NumPy, using comma notation, the row we want and then the column we want. So I want the value at row B, column Y, and this returns just a single value there. So if I take a look at my df again, looking at row B, column Y, I have this negative 0.84, and I get the same result here. So just like NumPy, you can use this row, comma, column notation. And if you want a subset of this, you can say df.loc and then pass in a list separated by commas. For instance, let's say I wanted the subset of A, B rows with the WY columns. So basically I wanted this 2.7, 0.9, and 0.65, and negative 0.84. That means I can just pass in a list of the rows I want, which in this case is A and B. And then I can pass in a list of the columns I want. In this case, that's W and Y. Shift enter that, and I get the subset return of the data frame. Okay, we're going to stop it here for now and continue this discussion in part 2 of the data frames lecture. And this is all in the notebook called Data Frames under the Pandas folder. Let's get a quick review of what we've learned. As far as creating a data frame, you just need to say pd.dataframe, pass in your data, pass in your index, and then pass in your column names. Usually, we won't be building data frames by hand in this manner. We'll actually be reading data from some sort of source, like a CSV file, but we'll learn how to do data input and output later. For now, if you want to manually create a data frame, that's how you can do it. Then, for selecting columns from a data frame, you can say df, and then in brackets, pass in the column you want, or pass in a list of the columns you want. Remember that each column is actually just a series. You can create new columns based off of old columns by using this sort of arithmetic. Then you can drop columns or rows using df.drop. Remember, you'll need to say in place equals true if you want the effect to be permanent. You say axis 1 for columns, and then axis 0 for rows. And again, that comes from this shape tuple. 0 index was rows, 1 index was columns. As far as selecting rows from a data frame, there's two methods here. There's the .loc method, which is a labeled-based index location, or there's the .iloc, which is the integer-based index location. And then if you want to select subsets of the data frame, you can use .loc and pass in either values or complete lists to return subsets of the data frame. Okay, that's it for the very basics of data frames. Coming up next, we're going to discuss even more of what you can do with a Pandas data frame, such as using conditional selection. Last time we left off on how to create a basic data frame and grab information from that data frame. Now we're going to look at conditional selection as well as some multi-index parts of a data frame. Let's go ahead and jump to Jupyter Notebook to get started. Alright, here we are back at the Jupyter Notebook. I'm going to be using the same data frame as last time. So remember we just had to say numpy is np, pandas is pd, import rand_n, set the c to 101, and then say the data frame was rand_n 5, 4. And then here we have our data frame. Okay, let's go ahead and talk about conditional selection. A very important feature of Pandas is the ability to perform conditional selection using bracket notation. And this is going to be very similar to NumPy. For instance, if I use a comparison operator against a data frame, such as asking where is the data frame greater than 0, I will get a data frame back of Boolean values, where it returns true if the data frame value at that point was greater than 0, and false if it was not greater than 0. And this is very similar to the same conditional selection applied to an entire NumPy array, except in this case, we're doing it with Pandas data frames. And just like this, we can go ahead and say bool df is equal to df greater than 0, and then say bool df, go ahead and check that out. And here we have our Boolean data frame. And if we pass that in to our original data frame with bracket notation, then we will get out as a result values where it was true and nulls or NaN where it happened to be false. And that's the way you can use conditional selection along with a data frame. Now usually you probably wouldn't be separating this out into two steps. You would just say df and then in brackets something like df greater than 0. And you would get this result. This sort of operation with a data frame and against a comparison operator isn't that common. What most likely you'll end up doing is instead of just passing in the entire data frame, you'll pass in a row or a column value. And instead of returning nulls, what that's going to do is return only the rows or columns of the subset of the data frame where your conditions are true. And let me go ahead and show you an example of what I mean by that. Let's go ahead and take a look at our original data frame. Here we have rows A through E and columns W through Z. What I'm going to go ahead and do is specify df of W greater than 0. And notice I get a series back. True, true, false, true, true. And this is linked to the actual index. And if I take a look at the W column, I see that this corresponds with the W column values. And the value at index C was actually less than 0, so it returns false for being greater than 0. I can now use this series of Boolean values corresponding to rows to filter out rows based off of a column's value. And that means if I pass in this series into a data frame using bracket notation to say something like df of dfw greater than 0, I will only get back the rows where this happens to be true, meaning I'll only get back the rows A, B, D, and E. It won't return row C since it was false here. Let's go ahead and run that and see what this looks like. Great. And now, since I'm passing in a series, I don't get those null values anymore. You only get those null values when you're doing this sort of condition on an entire data frame. When you're actually passing in conditions based off of columns, you'll just get series values, meaning you'll get only the rows where it happens to be true. And this is the sort of conditional selection we're going to be using most often throughout this course. Let's go ahead and show just a few more examples to really drive this point home. Let's say I want to grab all the rows in my data frame where Z is less than 0. So I say df, where df of column Z is less than 0. Now let's take a look before we actually run this, what should happen. Well, we'll notice column Z, where is it less than 0? Well, that's only occurring in row C. So column Z, as in Zelda, and then row C as in cat. Here, this is the only row that should be returned. But remember, we're asking for the entire data frame back, so it should return just this row C for us. And there it is. Okay, great. Now, something else to note here is that when you're doing these sort of commands, let's go ahead and go back to our W greater than 0, you get a data frame in response. And that means you can go ahead and call commands off of this data frame. And you can do this either in one step or two steps. I'm going to go ahead and say result df is equal to this, and then take a look at result df, which is the subset of the data frame without that row C in it. And that means I can go ahead and grab results off of this, such as X. And here I have 4 values of X, A, B, D, and E, based off of this resulting data frame that didn't have that row C in it, as in Charlie. But instead of actually separating this out into 2 steps, such as grabbing the X column, I can do this all in one step. And let me show you what I mean by that. I can go ahead and say, return the data frame where the column value of W happens to be greater than 0. So return those rows to me. And that means all the rows minus the C row. And since this is the data frame, I can actually go ahead and stack commands such as bracket notation on top of that, such as return the X column where that's true. And now I get the same results as I did up here, except it's all done in one step. And this is something that can be intimidating to beginners at first, since there's a lot of brackets and a lot of stuff going on here. But essentially, this is just, instead of splitting everything up into multiple steps, I'm putting it all into one step. And likewise, since this is a data frame, I can bracket for multiple columns by passing in a list, such as Y, X. And we can see we get a result here. Let me go ahead and break this line down one more time to show the steps that we're taking. First off, we're going to go ahead and say bool df is equal to, well, let's go ahead and say bool series, since it's a little more accurate, is where dfw is greater than 0. So if I say bool series, I get this Boolean series back. Then what I'm going to go ahead and do is say result is equal to df of that bool series. Let's go ahead and check out the result. And it should just be wherever that series was true, which is A, B, D, and E. And there is my result. That's the entire data frame without the row C in it. And then I can go ahead and off of that result, call a list of columns. So we can go ahead and say Y, X. And if we wanted to, we could actually even separate this out into one more step by saying my calls for columns, pass in that list, and then say result of my calls. And we get the exact same thing we have here done in one line, as in multiple lines. That means if you're ever confused on something that looks like this, of a ton of brackets and pandas, see if you can break it down into multiple steps, if that makes more sense to you. Throughout the course, we're going to be doing this type of notation, these kind of one-liners. And as you get more and more comfortable with pandas, you'll find yourself using these one-liners more and more often. But if you're ever confused, always feel free to break it down into multiple steps. The only disadvantage as far as breaking it down to multiple steps is that you are taking up memory with each variable that you define. So as you get better and better with pandas, you'll want to move towards this simple one-line abstraction of all these commands. All right, go ahead and pause the video now and really make sure you understand how line in 58 here is the exact same thing as separating it out into multiple lines. All right, let's go ahead and explore real quick the concept of using multiple conditions, such as 2 or more conditions. Right now, we feel comfortable with doing something like this, which is returning a subset of the data frame based off of one condition. But what if you wanted multiple conditions, such as where W was greater than 0 and Y was greater than 1? Well, what you could do is try something like this. Is in parentheses, pass in one condition, and then say and, pass in another condition. And this is going to return an error. And I'm going to do this on purpose to explain why there's an error happening here. And this is a common mistake for beginners to put this and here. And you'll get a mistake that says something about the series being ambiguous. If we scroll down here, we see this. The truth value of a series is ambiguous. And what that is trying to say is that Python's normal AND operator can't actually take into account a series of Boolean values compared to another series of Boolean values. An AND operator can only take into account single Booleans at a time. So true and false returns false, true and true returns true, etc. That means when you pass in an entire series of Boolean values, such as this, the AND operator begins to get confused. It can only deal with these single instances of Boolean values, which is why when you're working with pandas and you want multiple conditions, you actually have to use an ampersand, which is this and. So that's going to be Shift 7 on your keyboard for most standard keyboards. And notice here that I'm passing these conditions in parentheses to show clear separation between each of these conditions. And then if I run this, I get the row E where this happens to be true. Okay, let's go ahead and break that down one quick last time. When you're trying to use multiple conditions, you can't use Python's normal AND operator. You have to use the ampersand. And then you pass in the multiple conditions in parentheses, and then finally you put it inside of brackets for your data frame. If you want to do an OR operation, you can just replace this with the pipe operator, which is right above your, usually for most keyboards, on your enter key, go ahead and go right above it and then do shift on that, backslash, and this should give you the pipe operator. And that's going to be your replacement for OR, because if you try using OR, you'll get the same error. So that's with OR. If I try it with Python's normal OR, again, I'll get the truth value of a series is ambiguous. And that's because you get a series of those values instead of just 1 or 2 Boolean values. Okay, you can go ahead and reference in notes if you want more examples of this. But basically, if you want multiple conditions, pass in each condition in parentheses and then use an ampersand or pipe operator for the AND or OR. Let's go ahead now and shift gears to talk about index and a little more details about it. What we're going to discuss now is resetting the index or setting it to something else. Let me go ahead and take a look at our original data frame. I'm going to go ahead and clear these cells here by just running them. And let's take a look at our data frame. Again, we have rows A through E and columns W through Z. In order to reset the index back to the default, which is just a range index 0, 1, 2, 3, 4, all the way up to the nth row, what you can do is call the method reset underscore index. And remember to close parentheses that we actually run that method. And if you call that, notice you will get the index reset to a column. And you'll get the actual index then to be numerical. And that's how you can reset the index. Something to note here is just like a lot of other Pandas data frame operations, this doesn't occur in place unless you specify it for it to occur in place. So if I call back df, I still have that original index of labels. If you want this to actually occur in place, what you would just do is say in place equals true and pass it into the reset underscore index. For now, we'll go ahead and not do that. That way we still retain our original data frame. Let me go ahead and clear this out. Again, if you just want to reset the index to a numerical value, you can just use .resetIndex and your old index will become a column of your data frame. Okay, let's go ahead and show one more new index example, such as setting the index. And in order to do this, I'm going to go ahead and create a new index called new IND. And I'm going to use a little trick here that I'll explain in just a second. This is going to be a bunch of state abbreviations, and I'm going to say dot split on this string. And remember, dot split off a string is just a common method for splitting off of blank space. But this is a nice quick way to create a list instead of having to type out every comma. So I'm going to go ahead and set that list equal to new IND. So I have my new index values here. And what I'm going to do is put this as a column in my data frame. So I'm going to go ahead and say df states is equal to new IND. And since the dimensions match, so there's 5 items here, it will match from 0 to 4 here on this data frame. So if I check out my data frame, I have this new column called states. CANYWYORCO. Now we know how to reset the index, which is just doing the dot reset underscore index method. But if you have a column in your data frame that you want to be the index, what you can go ahead and do is say dot set index instead of reset index. For example, I can say df dot set underscore index and then pass in the column name you want to be the new index, such as states here. And if I do shift enter, now the states column has become the index. Keep in mind, unless you retain this information of the index, this will overwrite your old index and you won't actually be able to retain this information as a new column, unlike reset index that allowed you to have that new column. So that's set index versus reset index. Again, if I check out my data frame here, this wasn't in place. I would need to add the argument. If I do shift enter here, in place equals true. Let me go ahead and just do a quick review of what we just covered before we head up to part 3. Okay, we learned about conditional selection, which is very similar to NumPy operations. You basically get a data frame of Boolean values, and if you pass in a whole data frame of Boolean values, you'll get the values where it's true, and you'll get NaN or null values where it was false. If you pass in a series of Boolean values, such as a column with a comparison operator, you'll end up only getting the rows of the data frame where the series happened to be true. And you could break this down into multiple steps if you wanted to. Again, these 2 cells are probably the most important to understand out of this lecture. If you understand this, then you understand how to do conditional selection in Pandas. Then, scrolling down, if we wanted to do multiple conditional selection, you could do an ampersand or a pipe operator. You cannot use Python's built-in and or operators because of the ambiguous values in a truth series. And then remember to use parentheses to separate each conditional selection statement. Then finally, we have reset index. Reset index is just going to reset your index to a numerical index and take your old index and set it as a new column called index. And then you can set a new index instead of resetting a new index based off a current column just by saying set underscore index. And both these methods are not in place by default, so make sure to specify in place equals true if you want the change to be permanent. In this final lecture of the DataFrames series of lectures, we're going to learn about multi-index and index hierarchy. We'll first create a quick example of what a multi-index data frame looks like, and then how you can work with data frames that have a multi-level index. Let's go ahead and jump to Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. What I'm going to go ahead and do is copy and paste some lines of code that are available for you in your notebook called DataFrames. If you scroll down until you get to the multi-index and index hierarchy section, you'll see these 4 lines of code. These are the 4 lines of code we're going to use to actually build this data frame. We can go ahead and check this out. We'll say outside, and that's just a list. So we have 6 items in this list of 2 different types, G1, 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 and then G2, G2, G2. We have inside, which is 1, 2, 3, 1, 2, 3. And then what we went ahead and did was using the zip function along with the list function, is we said higher index. We went ahead and used zip and list on this in order to make this into a list of tuple pairs. So G11, G12, G13, G21, G22, G23. And then I passed it into a special function from Pandas. And we actually won't be working with this function at all throughout the course, but this is just for a customization of making a data frame. So don't worry too much about it, but I just want you to be aware of it. It's pd.multi-index from tuples, and it can basically take in a list that looks like this and create a multi-index from it. So after you're done with that, you'll get this multi-index with several levels. G1, G2 as one level, 1, 2, 3 as another level, and then labels. And we'll go ahead and explain what all that means as we create this data frame. But for now, you can just feel free to copy and paste this code directly from the notebook, since it's not important as far as creating the data frame from scratch. We'll go ahead and say pd.dataframe, pass in rand n 6, 2. So we'll have 6 rows by 2 columns. And then I'm going to set the index to be the higher index object we just made. And then I will set the columns to be a list of A and B. All right. And you can feel free to copy and paste all this code from the notebooks because it's not that important. This is just for actually constructing a multi-index level data frame. And let me show you what I mean by that. Here, if I actually show the data frame, I can see that it has 2 levels of an index. It has this G1 and G2 level, and then this sub or inside level 1, 2, 3, 1, 2, 3, and then 2 columns. And this is what a data frame looks like when it has multi-levels of an index, otherwise known as an index hierarchy. Let's go ahead and show how we can actually call data from a multi-level index. For this index hierarchy, what we can go ahead and do is say df.loc, and then we can go ahead and, using bracket notation, grab from the very outside index. For instance, if I want everything that's under G1, I can just pass in G1, and I get that little sub data frame in return, which is basically these first 3 rows for those 2 columns. And then I can continue indexing off of this, such as ILOC or .loc, either one's fine, and then passing in a number. And that will actually then return these 2 items here as a series. So the basic idea is you call from the outside index and continue calling inside deeper. If you actually want to name these index names, so right now they are unnamed, that's notified by the fact that there's no name in these 2 cells, which you can go ahead and do is say df index.names, do shift enter, and you should get a frozen list that's none, none. And this is just a pandas index names object types. All it's saying here is that these indices don't have any names. What you can go ahead and do is say equals, and then pass in a list of names. For instance, let's go ahead and call this outside index groups, because it starts with G, and then we'll call the inside index NUM for numbers. And now when I call my data frame, we have groups as a labeled index on the outside and num as a labeled index on the inside. And this can have as many layers as you want. Hopefully you can begin to see how this would be useful for multi-level index information that you want to use along with a data frame. Let's go ahead and show you how we can grab information off of this one more time. Imagine we wanted to grab this value right here, 0.072, the one I have highlighted. Well, that's under G2, number 2, column B. Let's start from the outside and work our way in. We'll go ahead and specify that we want .loc G2. And that returns this data frame. Again, we're looking for this value here. So let's go ahead and do one more index. And we can go ahead and call here 2. And then we have under column B, or index B, excuse me, for the series 0.07. So then finally we just call B at the end. And that's how we can grab all the way from the outside to the inside this particular value. What you should do now is pause the video, select another value, and see if you can successfully index it and return it back. Okay, hopefully you're able to do that. Let's go ahead and show you one last very useful function called cross-section, and it's going to be XS. So this returns a cross-section of rows or columns from a series of data frame, and you're going to use this when you have a multi-level index. So again, our data frame looks like this. Let's say we wanted to grab everything that was under G1. I could do what I just showed you, LOC G1, and that returns the data frame under G1. But another option for a multi-level index is using this XS, this cross-section, and then passing in G1 also as a string. But what's nice about this cross-section is it has the ability to skip or go inside a multi-level index. For example, let's say I have this data frame here, and I want to grab all values of number equal to 1 with both groups in it, meaning I want what I highlighted here, 1 and then 0.3 and 1.69, but also I wanted this value, 0.16, 0.18. So I want all values where num, that inside index, is equal to 1. This sort of indexing is tricky for something like .loc methods, but it's not so bad with the XS or cross-section method. What you end up doing is specifying what you want as far as num equal to 1, and then you have to indicate as a second argument level and then pass in the name of the index. In this case, the name of that index is num. So essentially this allows us to grab a cross-section where level equals num is equal to 1. And that's how you're mainly going to be using this cross-section. And now we see both groups where level num happens to be equal to 1, and this sort of data frame gets returned. Okay, don't worry too much. This is pretty advanced usage of pandas. I just want you to be aware of it. Thanks everyone, and I'll see you at the next lecture.